In our last exploration, we uncovered the hidden thirst of the digital age. We pulled back the curtain on the seamless, wireless world we inhabit, revealing the colossal physical infrastructure that powers our every click, stream, and search. We saw how our data-driven civilization, from the intricate dance of global finance to the simple act of sharing a family photo, is built upon a foundation of silicon and light. This foundation is growing at an exponential rate, a silent, voracious expansion fueled by the relentless march of artificial intelligence, cloud computing, and the Internet of Things. Every moment we demand more, faster, and smarter services, unknowingly feeding an engine of unprecedented scale and complexity. At the heart of this engine are the data centers, the factories of the 21st century, and just like the factories of the Industrial Revolution, they have an insatiable appetite for resources. We learned that these digital fortresses consume vast oceans of water and staggering amounts of energy, not primarily to process information, but for a far more elemental task: to stay cool. Every single calculation, every byte of data processed by the powerful chips that run our AI and internet infrastructure generates friction at a microscopic level. It's the fundamental law of thermodynamics at play. Energy in, work out, and heat as the inevitable remainder. This process creates a massive, invisible byproduct: heat, a constant torrential outflow of thermal energy. For every kilowatt of electricity used to power the servers, nearly another full kilowatt can be spent on cooling them, simply to prevent the delicate silicon from melting down. This isn't a trivial amount of warmth. A single large-scale data center can generate enough waste heat to warm tens of thousands of homes, yet we perceive it only as a problem to be managed, a fire to be constantly extinguished. It's a silent, invisible crisis happening in thousands of anonymous buildings scattered across the globe. For decades, this heat has been treated as a waste product, an expensive and inconvenient truth of the digital economy. The industry default response has been brute force, massive air conditioning units, evaporative cooling towers that consume millions of gallons of water, and complex liquid cooling systems. All of these are designed with a single purpose: to capture this thermal energy and vent it uselessly into the atmosphere. This isn't just inefficient, it's a multi-billion-dollar problem baked into the operating budget of every data center on the planet. It represents a significant portion of both capital expenditure on equipment and ongoing operational costs for energy and water, a financial drain that only grows as our data demands increase. We've engineered sophisticated solutions to throw away a valuable commodity. We've perfected the art of wasting energy. But what if we've been looking at the equation all wrong? What if our entire approach to this fundamental challenge has been short-sighted? For generations, we've defined this heat as a liability, a negative number on a balance sheet that must be mitigated. We've built an entire industry around its disposal. But in a world facing dual crises of energy demand and climate change, can we afford to continue thinking this way? The very definition of waste is being re-examined across every sector of our economy. We are learning to see closed loops where we once saw dead ends. It's time to ask a radical question. What if the single biggest problem of the data center industry, its greatest operational expense, its most significant environmental headache, was actually its most valuable untapped resource? What if this river of heat wasn't a waste stream to be discarded, but a product to be harvested, a clean, consistent, and locally produced energy source hiding in plain sight? In this journey, we will explore the innovative technologies and pioneering projects that are flipping the equation, turning a billion-dollar problem into a trillion-dollar opportunity, and transforming the very foundation of our digital world into a source of sustainable energy for our cities, our industries, and our future. Welcome to Eco Innovatech. In an era defined by data, our world runs on a silent, invisible infrastructure. Every search, every stream, every transaction is powered by vast, humming digital factories. These are the data centers, the beating hearts of our interconnected society. For decades, the primary goal in this industry has been a relentless pursuit of efficiency, squeezing more computational power from every watt of electricity. We measured success in fractions of a point on the power usage effectiveness scale, a metric that tells us how much energy is used for computing versus how much is lost to cooling and other overhead. This focus has driven incredible innovation, making our digital lives possible, but it has also obscured a fundamental and increasingly urgent truth. Today, we are not just looking at a more efficient machine, we are looking beyond the machine itself to the ecosystem it inhabits. The conventional model of a data center is linear and wasteful. It draws massive amounts of electrical power from the grid, uses it to run servers, and then spends even more energy to actively cool those servers, venting the resulting heat into the atmosphere as a useless byproduct. It's a one-way street of energy consumption. This model is no longer sustainable. As our demand for data grows exponentially, the environmental cost of this waste heat is becoming a critical global issue. We have reached an inflection point where simply making the machine more efficient is not enough. We must fundamentally rethink the machine's purpose and its place in our world. We are exploring a radical reinvention of urban design and a new paradigm for industrial ecology, the circular data center. This is not just a technological upgrade, it is a philosophical shift. It redefines waste as a resource and transforms the data center from an isolated and energy consumer into an integrated, symbiotic partner for the community around it. The core principle is elegantly simple. Instead of discarding the vast thermal energy produced by computation, we capture it, we concentrate it, and we repurpose it. This captured heat, a constant and reliable byproduct of our digital activity, becomes a valuable commodity. It's a paradigm shift that moves us from a linear model of consumption and waste to a circular one of integration and reuse, creating a closed loop where the outputs of one system become the essential inputs for another. Across the globe, a new generation of engineers and city planners are pioneering this simple but revolutionary idea. From the dense urban cores of Europe to the sprawling tech campuses in North America and the rapidly developing megacities in Asia, this concept is taking root. Instead of throwing away the immense heat generated by our digital world, they are capturing it, harnessing it, and using it to power our cities. In Stockholm, data centers are becoming the primary heat source for thousands of new apartments. In Montreal, the digital heat from server farms is being piped to nourish vast greenhouses, enabling year-round local food production. These pioneers are not just building data centers, they are architecting a new kind of urban metabolism where digital infrastructure and civic infrastructure are woven together. They are proving that what was once considered a liability can be our greatest asset in the fight for energy independence and climate resilience. This is the story of how the internet's waste heat is being transformed into a clean, reliable energy source for heating homes, growing food, and building the sustainable cities of tomorrow. Over the course of this series, we will journey to the front lines of this revolution. We'll meet the innovators developing the next generation of liquid cooling and heat capture technologies. We will walk through the district heating networks that are the arteries of this new circular economy, and we'll hear from the policymakers and economists who are writing the rulebook for this emerging sector. We will explore the challenges from retrofitting old cities to financing new infrastructure and celebrate the breakthroughs that are making it all possible. This is more than a story about technology. It's a story about reimagining our relationship with energy, our cities, and the digital fabric of our lives. Join us as we uncover the blueprint for a smarter, more sustainable future, powered by the very engine of the modern world. To understand the solution, we must first appreciate the sheer scale of the problem. A single large data center can consume as much electricity as a small city, but nearly 100% of that electrical energy is ultimately converted into heat. The waste heat produced by data centers in the European Union alone is estimated to be enough to heat every single residential and commercial building on the continent. For decades, the industry's sole focus has been on getting rid of this heat as quickly and cheaply as possible, using massive water-guzzling cooling towers that vent it directly into the atmosphere. We are simultaneously burning fossil fuels to heat our homes while spending billions on electricity to cool the computers that are generating more than enough heat to warm us all. This incredible inefficiency is the greatest engineering opportunity of our time. The most mature and powerful application of this idea is integrating data centers into urban district heating systems. In cities like Stockholm, Sweden, and in parts of Denmark and Finland, this is already a reality. Instead of using cooling towers, the data center's liquid cooling system captures the high temperature water from the servers. This hot water, often at 60-70 degrees Celsius, is then fed directly into the city's heating grid. The city, in turn, provides the data center with cool water, creating a perfect energy-saving loop. The data center gets its cooling for a fraction of the cost, and with a vastly reduced water footprint, the city gets a massive, reliable and carbon-free source of heat, reducing its reliance on fossil fuels, and the citizens get lower heating bills. It is a perfect example of industrial symbiosis, where the waste stream of one industry becomes the feedstock for another, creating a system that is more efficient, more sustainable, and more economically sound for everyone involved. The next frontier is using this waste heat to revolutionize our food supply. Greenhouses, especially in colder climates, consume enormous amounts of energy to maintain a stable growing temperature year-round. Data center heat is the perfect solution. Across the world, innovative projects are co-locating data centers directly with large-scale greenhouses. The hot air or hot water from the server cooling systems is simply piped next door, providing a constant, low-cost source of warmth that allows for year-round cultivation of produce like tomatoes, cucumbers, and leafy greens, even in the middle of winter. This creates a powerful, localized food system that drastically cuts the carbon footprint of both the data center and the farm. It reduces the food miles associated with transporting produce from warmer climates and increases a region's food security and self-sufficiency. A new generation of servers and chips is now being designed from the ground up with heat reuse in mind. By allowing chips to run hotter, cooling systems can capture smaller volumes of much higher grade heat. This high temperature water is far more valuable and can be used for a wider range of applications, from industrial processes to generating electricity itself using organic Rankine cycle turbines. Immersion cooling, where servers are submerged in a non-conductive fluid, is a game changer for heat capture. It allows for the transport of high-grade heat with minimal loss. If this idea is so brilliant, why isn't every data center a heat source for its city? The challenges are not technological but economic and logistical. Building the pipeline infrastructure to connect a data center to a district heating network is a massive upfront investment and requires close collaboration between private tech companies and public city utilities. Governments and city planners must play a role using zoning laws and incentives to encourage the co-location of new data centers where their heat can be used. For decades, the digital world has operated on a linear, extractive model. Data centers, the very hearts of our connected age, have been islands of immense computational power, consuming vast amounts of electricity, only to expel their primary byproduct, heat, as a worthless pollutant into the atmosphere. We built them to connect us, but in doing so, we disconnected them from the physical world they were meant to serve. The circular data center represents a profound shift in this paradigm. It's not merely an upgrade or an efficiency tweak. It is a complete philosophical and architectural reimagining of our digital infrastructure. This model marks the moment where the digital world begins to physically reintegrate with the real world in a symbiotic, regenerative way. The core principle is simple yet revolutionary. Waste is only waste if you waste it. By capturing the thermal energy generated by servers, we transform a costly liability into a valuable community asset. This is made possible by a crucial technological evolution away from traditional air cooling. While effective, air cooling produces low-grade diffuse heat that is difficult to capture and reuse. The shift to advanced liquid cooling, and particularly direct-to-chip or immersion cooling, is the key. These methods capture heat in a much more concentrated and usable form, typically as hot water, which can be efficiently transported and integrated into other systems. It is a vision of a future where our digital infrastructure doesn't just connect us, but also warms us, where the energy we use to process information is the same energy that grows our food. Imagine a data center co-located with a vertical farm. The consistent year-round supply of low-cost heat allows for the cultivation of fresh produce even in the coldest climates, reducing food miles and strengthening local food security. Now extend that vision to an entire neighborhood. The same hot water can be piped into a district heating network, providing carbon-neutral warmth to thousands of homes, schools, and offices. This isn't science fiction. It's happening now in cities across Northern Europe, where data centers are becoming integral components of municipal energy grids. The applications extend even further in scenarios where the heat demand is lower, or the temperature of the waste heat is particularly high. It can be used to generate more electricity. Technologies like the organic Rankine cycle can convert thermal energy back into electrical power, creating a virtuous cycle where the data center helps to power itself. From an economic standpoint, the circular model fundamentally alters the financial equation of a data center. While there is an initial capital expenditure for heat recovery and distribution infrastructure, the long-term operational savings are substantial. The need for expensive, energy-intensive chillers is drastically reduced, and a new, stable revenue stream is created from the sale of heat. This transforms the data center from a simple cost center into a multifaceted utility, improving its return on investment and making it a far more attractive partner for urban planners and investors. This is not just a clever engineering trick, it is a fundamental rethinking of what a city can be. It's a move away from siloed, inefficient systems towards a holistic, integrated urban metabolism. Urban planners are beginning to see data centers not as industrial burdens to be zoned on the outskirts of town, but as vital anchor tenants for new eco-districts. By designing our cities with this digital thermal symbiosis in mind, from the outset, we can create communities that are inherently more efficient and resilient. The reliability of the grid is enhanced, carbon emissions are slashed, and new economic opportunities are created at the intersection of the digital and energy sectors. Of course, this transition is not without its challenges. It requires unprecedented collaboration between data center operators, utility companies, and municipal governments, but there are logistical hurdles in retrofitting existing cities and technical questions around heat storage and managing fluctuating demand. And the heat produced by a data center is incredibly consistent, but the name of that heat in a city is not. Solving this mismatch with thermal storage solutions like large insulated water tanks or underground geothermal boreholes is a critical area of innovation. Furthermore, the environmental benefits must be carefully weighed. While circular data centers dramatically reduce carbon emissions and the urban heat island effect, the move to liquid cooling also significantly cuts water consumption compared to the evaporative cooling towers used in many large facilities, a crucial benefit in an increasingly water-stressed world. Ultimately, the circular data center proves that by intelligently designing our systems, we can turn our greatest liabilities into our most valuable assets. It demonstrates a future built on synergy, not extraction. It shows that the digital transformation and the green transition are not separate challenges, but two sides of the same coin. By weaving our digital infrastructure into the very fabric of our communities, we are creating a world that is not only more connected, but also more efficient, resilient, and sustainable for generations to come. This is the blueprint for the city of the future, a city powered, connected, and warmed by the same elegant, circular flow of energy. Could your city be powered by its data centers? Let us know your thoughts in the comments. For more on the innovations building our sustainable future, subscribe to Eco Innovatech. Thanks for watching. Settings, cinematic narration, calm and inspiring tone, with futuristic yet warm sound design, optimistic pacing.